Hey guys, welcome back to a tutorial on creating Tetris within Minecraft. And in this tutorial, I wanted to talk to you guys about the game state and sort of define that and crystallize that for you a little bit further. So the game state is essentially how the game knows at a particular moment to draw things a particular way, or to do things in a particular way. Okay, so ultimately it's a set of data that allows us in our game logic to properly do things, to do things right. Okay, so it's sort of like, if you're imagining we're playing the game, how does the game know, and this is our game board and everything, how does the game know that it needs to be drawing an I block right here at this particular location rather than drawing it this way, and rather than drawing it down here? Well, the answer is the game state data. So we need to store some variables that handle or that represent the block's type, whether it's like an I or a J. We need to also store the current block's orientation, whether it's sideways or upright, so that we can draw it correctly. And then we also need a special way to track the block's position. Alright, so let's go ahead and move over to the code, and I can show you guys how I'm doing this, and there's a bunch of different ways to do it, but the way that I'm doing it is called enumerative data. So enumerative data is essentially, it's just numbers 0 through some other number that are assigned to a particular variable name. So you can see that I'm in this define blocks function. All it's doing is declaring global variables. So I'm setting a capital I to 0, capital J to 1, capital L to 2, etc. Alright? And then define orientations. I'm setting upright to 0, right side down to 1, upside down to 2, left side down to 3. So what this does is that when we run our program and main happens, we call these define blocks and define orientation functions. We're just telling our application scope that 0 means I, J means 1, or 1 means J, L means 2, etc. And what that allows us to do is to easily make evaluations in our game's logic to differentiate an I block from a J block so that we can draw it differently. Alright, so that's the blocks type and the block orientations. But what about the position? So the position, and this is sort of overlapping into the next tutorial that we'll be doing, where we'll cover like how to render things. But the way that we're going to track position is with a cursor drone. And that's handy because you can move drones in a particular direction. It's really easy to move a drone in a particular direction, and it's also really easy to use a drone to place blocks. So that makes it a really handy tool, the drone, in tracking position, because not only will it track position for us, but it'll help us drawing our blocks. So that's why I'm using a cursor drone. So you can see this: set cursor drone to new drone, move cursor drone to me, and then we're actually moving the cursor drone forward to the initial position, which here I define as 20, and we're moving up a distance of 18. And by the way, the initial position I'm setting to 20 here so that I know where to paint the background, and I also know how far up or how far forward I need to move the cursor drone. So if I want to make the game board, so to speak, be closer to me, all I have to do is change this one variable of initial position to 15 or 10, and that'll make it so that that game board gets rendered a lot closer to me. But I've found that that 20 is a pretty good spot to keep it all visible as you're breaking those glass block controls. So, okay, so the cursor drone, and then check this out. So we also, since we have our cursor drone forward and up at the proper like spawn location for the blocks, we're also going to conveniently set this block spawn point to the cursor drone's current location. So now we have this block spawn point saved as a location, so we don't have to worry about moving, like reperforming these move cursor drone forward and up operations. We just have to say cursor drone's location, set it to the block spawn point from now on. So it'll be super simple. Okay, so that's how we're tracking the location. Now, like I said earlier, all of these things, the position, the block type, and block orientation, the reason we need to track them is so that we can make evaluations in our game logic that will help us do things a particular way. So we need to place blocks in a particular shape based on the type of block that it is, and then also the block's orientation. Alright, so let's go through the logic just a little bit so you can see it on a high level. So when main kicks in, let's just go to draw block. So we went with this draw block function that you see here. We pass in our cursor drone, i.e. position, and we pass in our current block type and our current block orientation. And oh, by the way, so current block orientation starts out at upright, and then current block type, you can see, is a random integer from 0 to 6, which you're thinking, why does the block type go from 0 to 6? Oh yeah, it's because the block types are 0 to 6. That's what they're represented as. So when you see current block type is equals random integer from 0 to 6, we're just assigning a random block type to this block type variable. Now in our draw block function, if we go to that, which I think I have my rendering up here, what are we doing? So we're setting a local draw drone to new drone. So this is just a little helper drone that we're declaring, and what we're going to be doing is we're getting locations, and I'll explain why we're getting locations in a second, but or in the next tutorial. But let's go to the get locations. So current cursor drone, block type, orientation. Okay, so that's what we're passing into get locations, and let's go to get locations. Here it is. Okay, so in get locations, you can see that there's all these evaluations taking place. Like if block type is I, we're going to get I locations. If block type is J, then we're going to get J locations, etc. So let's see what's happening in the get I locations, or get some locations. Okay, Z. So in the get particular letter or particular block type locations, here's what we're doing. We're making all these evaluations based on the block's orientation. Right? So we've narrowed down what kind of block it is. Now we need to narrow down the orientation that it is and do things in a particular way. Alright? And again, we're just skimming this right now. So next time we'll go into how we're drawing these blocks and solving sort of a more long-term problem with all this, and having like minimal repetition basically in our code. All right, so that should really help you understand the game state, and by now the overall game logic, like the game loop and the controls that I mentioned in the previous tutorials. Okay, so in the next one we'll figure out how we're going to render these blocks and update their positions and all of that. Okay, so thanks for watching, guys.